Welcome back to our second video of writing a convolutional neural network for image classification. In the previous video, we started by writing the convolutional neural network model class. We also tested it. Now we're going to write hyperparameters, device, model, optimizer, and loss function in this video. So as for the hyperparameters of our model, the one input here, number of output channels. As I mentioned to you, these numbers are basically very important because they decide how complicated the model would be and how much of calculations we would like the model to perform on our images. The heavier it is, the higher these numbers, the heavier the model, but perhaps the model would be more closer to something that would give us extract more information from our images. So that it's basically there's some upside and some downside to increasing these numbers, but we definitely want to have the capability of changing them, so we define them as hyperparameters. Conventionally, hyperparameters are all capital letters, so I'm gonna do the same thing, num out channel, and at this point I'm going to define them to be the same thing, 8 and 16. It could be anything. It could be 64 and 128, and we can go as high as we can with these numbers. Image width and image height are also two values that I'm going to set as hyperparameter, because we can change them and we can basically rescale our input images so that they would have these values. So we definitely would like to keep them as hyperparameters. Obviously, batch size, that's the size of our mini batches that we're going to keep as a hyperparameter, and the number of epochs, I'm just going to use 10 epoch. Let's just set it to 4 epoch because this is just for the sake of illustration. And the learning rate of our optimizer, we'll set it to 0.001. And obviously all of these values are set as hyperparameters, again, because we do want to have the capability of changing them. Defining the device. We always go by the idea of saying CUDA if torch dot CUDA dot is available, else we want CPU. And I also want to print the device to make sure what kind of device I do have access to. If I'm using my local machine, I definitely know whether I do have CUDA or CPU. But in this case, I'm using Google Colab, so sometimes we don't know it, and the GPU that we have asked for is turned down, and you have a CPU, so you basically need to know it every time that you're running your Google Colab notebook. So let's just have it in front of us printed. For optimizer, I'm gonna use the, basically call it optimizer is from the optim submodule. I'm gonna use the Adam optimizer. And remember, Adam requires model.parameters. It basically needs to know which parameters it's optimizing and what learning rate it has to use, for which I do have a hyperparameter. And I also need to define the loss function, and I will call it a criterion. And for that we use the NN submodule, and the cross entropy loss is a very good loss function that many people use it as their loss function in order to minimize the the inaccuracies of the model. That's basically what we calculate during, with the loss function. So our job with this video is done. We defined our hyperparameters, device optimizer, loss function. I'll see you in the next video where we are going to do something very interesting. We're going to download our data set, and once we downloaded it, we're going to visualize the images. And this next video has nothing to do with machine learning specifically, but it's very cool because it has to do with visualization and looking at the data. So it gives you some capabilities. Specifically, if you're working in the field of computer vision, you have to have the skills of bringing up the images, being able to show what was the raw image and what I am doing on it by passing it through my convolutional neural network. So that is something that we will learn in the next video. I'll see you there.